Now let us consider normal reaction. So what is this normal reaction? Let us imagine a body on the horizontal table. We know that weight of the body mg acts vertically down. Then why it is not falling down? If this is the only force acting on the body, then body must fall downwards. It is not falling means, according to Newton's first law, the net force on this body must be equal to 0. There must act some force on the body in the upward direction. That is defined as normal reaction, R or N. So, basing on this, we can define it as the force exerted by the lower body on the upper body perpendicular to the surface in contact. This is the contact surface. To this contact surface perpendicularly, the force exerted by the lower body on the upper body is called normal reaction. It is the force exerted by the lower body on the upper body perpendicular to the surface in contact. So here R is equal to mg. When a body is placed on the horizontal surface, normal reaction is automatically equal to its weight. Now suppose if the same body is placed on the inclined plane. Say this is an inclined plane of inclination theta, body is placed. Now what are the forces acting? The weight of the body mg, always vertically down. Normal reaction, according to the definition, force exerted by the lower body on the upper body perpendicular to the surface in contact. So this is R. Now resolve this mg into components. So what is the component present along this direction? If this angle is theta, then this is 90 minus theta, then automatically this angle becomes theta. So component close to the angle is cos. So mg cos theta. That means your R must be equal to mg cos theta when it is placed on the horizontal inclined plane. On the horizontal surface it is mg, inclined plane it is mg cos. Now take perpendicular. A body is pressed against the wall. This is a wall and body is pressed like this, say with a force F. This is the wall. So what is the normal reaction? So normal reaction is the force exerted by the lower body on the upper body. Now body is upper one, wall is the lower one. So lower one applying force. This is normal reaction. So from the figure, this F must be equal to R. So R is equal to F. So in the case of body is placed on the horizontal surface, R is mg. On the inclined plane, R is equal to mg cos theta. And pressed against the wall, R is equal to F, equal to the applied force. Now let us consider a body on the horizontal surface. We know that normal reaction acts upwards, weight acts downwards. So because of this, body is at rest. Imagine a pulling force P is applied like this. We know that immediately there develops a friction. Let us imagine body is ready to slide. So P is equal to Fs. Body is ready to slide. So here we have total 4 forces: mg, pulling force, normal reaction, friction. Now calculate what is the resultant of normal reaction and frictional force. This is one force, this is another force. So if I calculate the resultant will be like this. So I'll call it as Fr. It is the resultant of normal reaction and limiting friction. What is the angle made by this resultant? Let us say lambda. So if I complete this triangle, so this side is R, this is Fs, means this side is automatically Fs. So from the figure, tan lambda is equal to opposite by adjacent. So this is defined as mu s, coefficient of static friction. and this lambda is called angular friction. So angle of friction is defined as the angle made by the resultant of normal reaction and limiting friction with normal reaction. So this line represents R and Fs resultant, and the angle made by this line with normal reaction is called as angle of friction. Tan of the angle of friction is equal to mu s, and which is nothing but Fs by R. This is a coefficient. This is a constant value. In the similar way, you can define mu k, some Fk by R, and mu R, rolling friction coefficient, Fr by R. We know that Fs is greater than Fk is greater than Fr, implies your mu s is greater than mu k is greater than mu r. Mu depends on nature of the materials. It is independent of velocity or applied force. It depends only on the nature of the materials. Mu value is always between 0 and 1. It can never be greater than 1 or less than 0. Negative values are not possible. Mu always lies between 0 and 1.